Hello everyone, welcome to my channel Physics with Bhatt. To learn concepts of physics, subscribe this channel and press the bell icon button to notified of every new video. In today's video lecture, we will talk about the coherent and incoherent sources. In the last 4 lectures, we discussed the idea of wavefront, Huygens principle, refraction and reflection of plane wavefront. In the same sequence, here we will talk about coherent and incoherent sources. We know that terms related to the waves are wavelength, frequency, amplitude, time period, phase, and phase difference. So these are the basic terms related to the waves: wavelength, frequency, amplitude, time period, phase, and phase difference. Wavelength is distance of one cycle, distance between two consecutive crests and troughs. Frequency is number of cycles or number of vibrations per second. Amplitude is the maximum displacement from the mean position. Time period is time taken to complete one vibration or one oscillation. Phase and phase difference, these two are similar. Sometimes we use phase and sometimes we use phase difference. Phase difference is used if we are having two waves, then we use phase difference. Understand these terms related to waves, we consider equations of two waves. The first one is y1 is equal to a sine omega t, and second one is y2 is equal to a sine omega t plus phi. So these are the equations of two waves. If we consider all these terms which are listed here, then we can understand and identify these particular quantities in these two equations of the waves. A is amplitude. In both the equations, A is amplitude. Amplitude is same, and it is A in both the cases. Frequency is also same. Or what is the symbol of this frequency here? Omega. Phase difference, this phase difference is phi between the two waves. So these are the particular quantities which we have to understand in talking about the coherent and incoherent sources. So once again I just tell you, I have taken two equations of waves here. Y1 is equal to a sine omega t and y2 is equal to a sin omega t plus phi. In these two equations, amplitude is same, which is denoted by a. Frequency is also same, which is denoted by omega. Phase difference between two waves is phi. Likewise, we can talk about time period also. We can express this omega in terms of linear frequency as well. Omega is equal to 2 pi f. So if we talk about the coherent and incoherent source, then we have to write two sources are said to be coherent if they produce waves of number 1 same frequency or wavelength, and number 2 is phase difference between the two waves is constant. So these are two important parameters for two sources to be coherent, and these two conditions are the waves originated from the two sources having same frequency and wavelength, and phase difference between the two waves is constant. If these two conditions are satisfied, the sources are said to be coherent. Otherwise, the sources are said to be इनकोहेरेंट. इट मीन्स अगर ये दोनों कंडीशन सेटिस्फाई नहीं होती है, यानी जो दो वेव्स हैं उनसे ओरिजिनेट होने वाली वेव्स की फ्रीक्वेंसी या वेवलेंथ सेम नहीं हो और उन दोनों के बीच फेज डिफरेंस कांस्टेंट नहीं हो, तो ये सोर्सेज इनकोहेरेंट होंगे. सो प्लीज रिमेंबर दिस टू कंडीशंस, that frequency same and phase difference is constant. How to understand this? This is possible only if positions of the two sources are fixed, the positions are not changing randomly, then the sources would be coherent sources for the particular point of interest where we want the wave reaching to be. To understand this diagrammatically, I just take here two sources S1 and S2. Let our point of interest is P. At this point, we are just thinking of that the waves originated from these two sources approach. So these sources would be coherent if S to P, the path difference is equal to S2P minus S1P. If part difference is constant, then definitely phase difference would also be constant. In that case, the second condition of sources to be coherent is satisfied. Moreover, if they produce the waves of same frequency, is omega, then these two sources would be coherent. If the positions of S1, S2 or this point P are changing, then definitely these two conditions, out of these two conditions, the second condition of phase difference constant will not be satisfied. In that case, these two sources would be incoherent. So same frequency depends on the nature of sources. If they are having the same source, then definitely the frequency would be same. Now, one important thing we have to understand, that is interference. If two waves originated from two coherent sources propagating along same direction superpose each other, then interference occurs. As a result, amplitude of the resultant wave is found to be maximum at some places and minimum at some other places. So this phenomenon is known as interference. Interference is of two types. Constructive and destructive. As you can see here, interference at some places amplitude is found to maximum. At those places constructive interference occurs and amplitude is found to minimum. At those places destructive interference occurs. So these are the two types of interferences. I discussed the fundamental concepts, coherent and incoherent sources with you. Next video we will talk about specifically about interference, how this interference occurs and what would be the equation of a resultant wave. So I hope you understood the concept of coherent and incoherent sources and interference of the waves also. We will meet very soon in the next video lecture. Till then, take care of yourself, keep watching, keep learning.